So, hi guys, my name is Matuska. I'm from Bratislava, Slovakia. I'm quite a new FreeBSD developer, but what I will be talking about is a project of mine that started 3 years ago. The name of it is mfsBSD. What does it do and what it is? It will be the contents of my presentation, and at the end of my presentation I will give some kind of a live demonstration how I actually build mfsBSD works. I won't compile it, you can try it at home or at work, but I will show what it can do. So, what will this presentation be about? So I would like to show at very first what is mfsBSD, what I'm talking about. The second point, where does it come from? Is it completely my idea, or did I steal this idea, or did I continue somebody else's idea? We'll see. Next point, who is it made for? Is it, what are the groups I target with this software? We'll see. Next point, how do I personally use it? It's also quite interesting. And finally, I have already given a very short presentation in 2009 in Cambridge, and I will show what has changed since 2009. So here is a short overview, and there is a line at the top of the presentation. So what is mfsBSD? mfsBSD is a BSD license set of scripts that creates actually a FreeBSD distribution that's runnable. And this distribution is very small sized. So the actual size is below 30 megabytes when we are using the new XZ compression that has been imported recently. And it's rich featured. What's removed, there are no docs, there is no man, and recently I have also remote named, because if it's included, the name, its libraries and daemons, it takes like 5 megabytes added to the code base. I mean, it is possible to include it if somebody modifies the script set. So the main point of the whole thing, it's based on mfsroot. That means the complete distribution runs in mfsroot, it boots into mfsroot, everything is in mfsroot. That means after booting mfsBSD, you do not need the original device anymore, the media. That means you can remove it, you can boot a different machine, or you can boot it from network and so on. So it is customizable. That means you can add user packages to the system. And the very latest thing, I have written a short script that is called ZFS-install. It's a command line script, and with this script you can use mfsBSD to do ZFS-on-root installs of FreeBSD very easily. Good. The idea of mfsBSD originates from a depenguinator project from Colin Percival. Anyone of you knows this project? Yeah. So what was depenguinator actually about? It was a project started to enable FreeBSD on dedicated servers. There are many dedicated server providers out that offer Linux servers. I mean, you can buy a Linux server from them, you get Linux pre-installed. I mean, nowadays, many providers offer you already some kind of a remote console with ISO support and so on, but many don't. And in like 3 years ago, there was like almost no one, or even if they were available, it was very expensive, these dedicated servers. So what Colin Percival did was actually picking a Linux server and overwriting this server with FreeBSD that boots. Just and doing restart and rebooting it, running in FreeBSD. Just to give you some clue what time was it, or what FreeBSD version was with depenguinator. Depenguinator was originally written for FreeBSD 5. That was the first version, and it has some drawbacks. Since January 2009, there has been someone who sponsored Colin to make his depenguinator work with FreeBSD 7. So he did some patches, he was paid for that. And depenguinator also worked with FreeBSD 7. Okay, what does depenguinator do? It focuses really solely only on reinstalling these Linux systems remotely. But this idea can be used in much wider ways, and I will show you shortly which ways are these. And of course, it creates only disk images. That means you can create only a disk image that can be then deployed with DD on a disk or on a partition, and then boot in Linux. My very first dedicated server was at a German service provider called NetDirect, and they offered like Linux servers, but without console. Everything I had was remote reboot or via web interface reinstall of the original image. That was everything I could do from this interface. So I used depenguinator at that time. I have overwritten with this FreeBSD. This is booted. I've logged in with SSH and installed the whole system from the internet. And I had a FreeBSD server, even if this service provider didn't offer it. So what's the history of mfsBSD? I started it because depenguinator was not offering me everything I wanted, so I wanted to improve it. So I started the project in 2008. That was the first changelog entry. To show in 2009, I dropped FreeBSD 6 support and added this zfsinstall script. Then with version 1.0 in 2010, I was already creating bootable ISOs. That means you have some kind of a live CD for FreeBSD. That's MFS based. That means you just insert the CD, boot mfsBSD, you can pull the CD out and like boot 5 and other machines and whatever. So what's the current state of the script set? I have built-in support for bzip2 and xz. The original set I had has been using only geom-uzip for compression of the USR file system. That has again some drawback. It was mounted read-only. That means a user cannot change or modify or whatever afterwards the USR file system. And to reduce size, in the installation, I have replaced or just hard link, soft and hard link parts of the rescue system. So this one big binary was linked, and that saved again several megabytes of data. Good. Who is the target group of mfsBSD? Who I wanted to use? Of course, first group are system administrators who want to do like system diagnosis or installation of FreeBSD. And of course, power users who want to have full ZFS on their notebooks and don't have time to study all of these instructions in the internet. I mean, to read them is no problem, but you have to also understand them and make no mistakes if you run this. That's many people, when they see these wiki pages, told me, okay, I don't go into this. So here you have a script that does everything for you. Okay, developers. Why developers? I found it pretty useful for kernel testing in VirtualBox. I am doing some ZFS stuff recently, some of you might have noticed, and I use this to test the ZFS module in a virtual environment. It's really quite useful to debug, to do backtraces and so on, without booting my computer 10 times. Okay, dedicated server providers. There is a very big German dedicated server provider. I don't know if any of you knew it. The name is Hetzner. Yeah, they are selling dedicated servers in really bulk numbers, and they have some FreeBSD friendly admins, maybe, and these admins have included this mfsBSD to their system. And how did I find it out? I actually had FreeBSD before, using mfsBSD just by rewriting Linux before. And one day I log into the systems I have there, pick a rescue system and see FreeBSD in the list. I say, hey, how can this be done? I know only my solution, and that's the solution from mine. So I booted, and what I see that is really my name inside. So I asked them to put it also on the wiki page that they built it to give some credits, because BSD license don't offer you force you to say to give out the code, but you still have the right for credits. Okay. So, and finally me. I'm also my target group. Okay, so how do I use it as a very important target group of mfsBSD? Of course, the main thing when I install new servers and I want to have them full ZFS, then I do it with mfsBSD. Another thing, I want to install these servers remotely without console access or anything. That's like with the service providers. It's also a point. Another point, a rescue system. If something screws up or my system doesn't boot or whatever, I can use mfsBSD to boot it, and I have also using it in network environments. You can easily make DHCP and TFTP boot mfsBSD, and you can work with these systems remotely. So, and as I already said before, kernel testing in virtualized environment. So, what do you need to make your very own mfsBSD distribution? Well, you need the code, the scripts itself. You need FreeBSD source files. You can take the source and compile it, or you can pick installation media. If you want ISO files, you need CDR tools from our best friend Jörg Schilling. And well, he's in the Open Solaris committee now, in the core group there. So, and cross-building is possible now also. That means you can build your distribution for a different architecture, make this mfsBSD, and then it will run on this different architecture. To say now, I have tested only AMD 64 and i386. That works without problems. If someone is ready to test it on different platforms, I would be happy. Oh. Okay, the main file of the system is the make file, and in this make file there is a really large number of options now that can help you. You can then choose if you want to install from a media, if you want to make it from just compiling, if you want mfsBSD to do the compiling for you from the sources, and so on. Like compression algorithms, all of that can be chosen by options, runtime. So runtime requirements, what do you need to run it? Okay, the system needs to be able to run FreeBSD, very important. It should be also be able to boot FreeBSD from somewhere. So if you have a system without HDD, CD-ROM network, or any flash media or whatever, of course you cannot boot anything, and also not mfsBSD. So the last problem, RAM. Because mfsBSD runs completely in memory, I would recommend 512 megabytes. I mean, you can run with like 384. It should be possible, but I start with this number. So I mean, if you have really embedded devices, I don't think that mfsBSD is yet the solution. But that might be improved in the future. So what tools and features are used in mfsBSD? What do we have there? Of course, mfsroot feature of FreeBSD that we can boot in a memory file system directly. That's read from loader. I'm compressing the user file system. Currently, I prefer this one. It compresses it has the best compression ratio, and the decompressed is about twice as fast as bzip2. And at the very beginning of it, I have been using only geomuzip. Partially, makefs from NetBSD is used to create disk images if you want. And mk-isofs from CDR tools if you want to create ISO images. That's actually everything you need. You don't need any additional tools. So how does it work? There are 4 custom RCD scripts in mfsBSD. One of them is the, let's say, very important one. That's md-init. It's launched very early, and it creates the user file system for you from this compressed file. Then we have the mfsBSD script that sets the root password and other features. I will show them later. there is a special interfaces script that still remain from Depenguinator. It's a script that helps you setting IP addresses on interfaces by their MAC address. That means you can define IP address by MAC address on the interfaces. That's again from Linux. That means when you are switching from Linux, it might happen that in Linux you can actually find out what network driver is the hardware using, because there you have like ETH0, ETH1, and so on. And it's not that easy to find out which corresponding driver in FreeBSD will be the correct one. So finally, packages. Packages is a script that just installs user-supplied packages from a directory provided. Okay, the input, it's like two options. You can input from FreeBSD installation files like a CD-ROM release or NFS or whatever. You just need these files in the distribution. Or you can build your very own custom kernel vault for testing or whatever. So output types are again three. We have ISO images, we have a tar distribution, and we have a raw image. Why these three? ISO images are good if you want to boot from CD, or if you have a remote server and you have access to its CD-ROM, you can just boot the CD-ROM. Then tar images, if you want, for example, network boot, or just extract these files in a distribution, you use this option. And finally, a raw image. That's very hardcore solution. That is, if you have Linux installed, you can use DD to overwrite its very own partition. In some situations, it's work that you really can just overwrite it, but you still have the risk that Linux will write something in the partition. So at the very first dedicated provider I have been working with, they had like two partitions, a very big root partition and a small swap partition. So what I did, I moved Linux into this small swap partition, then booted again from this swap partition, rewritten the root partition, booted again, and then I had SSH access to FreeBSD. Okay, as I create ISOs, I'm also offering ISOs on my website so that everyone who wants can download and test them. I have two editions. One of them is the standard one. It's a very small one, like 30 megabytes. The second one is a more interesting one. That's the special edition, and it includes a FreeBSD install world in a compressed file. And with this edition, you can actually use this file to install FreeBSD on a ZFS-only system. So really only ZFS file systems inside. So the configuration files inside, so you have the ability to modify loader conf to your needs. There are some key kn variables I will show later. I have added to make things easier, because when you have already created an image, editing is quite complicated. You have to like extract the image, you have to mount it via MD, then you can just change some stuff inside and have to again demount it, again compress, and again create, for example, an ISO file. That's not so easy. If you have already a ready image, then you can just adjust some files on the fly, just by getting to the loader prompt at the very beginning of the boot process, and you can just pass in some kn variables. Okay, rcconf initializes the var file systems, the mp file systems, of course, very important. If you have no console access, starts SSHD for you. Interfaces conf, this is, as I said, IP interface by MAC, and resolve conf sets name servers. And this was a request of my users. They wanted to have authorized keys also a part of the configuration, so they do not have to set a root password or boot in with a root password just to get in with the key. So let's take a very quick look at the variables. So the very first one, what I have added a simple script that just goes through all interfaces in the system and sets them to auto DHCP. So if you have a DHCP environment in a network, you actually only have to set this to on and to yes, and all your booted devices will automatically get an IP address. Second one is the root password. Then we have name servers. All these variables are kernel variables that can be set in loader conf, or even if you escape to loader, just to override what happens afterwards. So if you want to change that, you can change the host name, you can change interfaces, you can specify how these interfaces should be set. Everything can be set in this context from loader.conf, because each distribution of mfsBSD, the loader.conf is outside of the mfsroot, so it's editable. So now the very interesting part of this, we have the ZFS-install script, and that's the very new thing. What does it do? It installs full FreeBSD with ZFS-on-root. This installation supports the mirror and RAID Z mode. That means you can install it on more disks at a time in mirroring mode. Supports standard swap partitions. That means you can tell him that you want the GPT install with of course, the boot partition has to be always there, but if you want a separate swap partition, and the last partition will be ZFS. Of course, you can also specify the size of the ZFS partition and keep some empty hole inside. So it supports compression, again per flag, and you can set Fletcher Forrest the default algorithm. So a script I had to, again on request, to edit, it's called destroy geom. If you have a gpart created file system, you cannot just tell gpart to like recursively delete what's inside. So what this script does, it recursively deletes all the subpartitions, and then it deletes the main partition. It's a support for ZFS-install to clear disks. You can tell it also to destroy zpool if it's already on this disk installed. And what I'm missing there, it is working now only by one level. That means it has only one level inside, and if you have like very nested partitions, it doesn't delete them yet. But it does delete what mfsBSD creates. So what ZFS-install creates, this script can delete it without problems. Maybe if you make a mistake or something and you want to reinstall it again. So now I would like to show you how such a ISO works. You sure know Oracle VirtualBox. Oracle has been working on it for years. So what is now happening, I mean, the kernel was loaded, and now the mfsroot is loaded. This notebook is not fast. It's one of these Acer long battery life notebooks. So it takes some time. Then we have a standard FreeBSD login prompt. Actually, mfsBSD was configured to boot from an ISO. So it's an ISO file, and the system boots from it. As you can see, this is again some of my stuff. So going online. So know what's happening, why we are waiting a little. I am now installing Python and PyZFS. Because this is my test image for ZFS v16. That's what I'm having here. Okay, so now we have a login prompt. So and now we are in. As you see, there is a welcome message that shows some instructions what can be done to make this work, or to install the FreeBSD. So what we actually have to do is mount the CD device. exactly as in the instructions. On the device, we can see we have a FreeBSD distribution file in XZ. Let's see how big it is. So the distribution file has 66 megabytes compressed. So that's actually a complete install word inside, and a generic kernel. Let's see the size of the mfsroot. That's 28 megabytes. And the size of the kernel is the generic one, it's 5 megabytes. So that's actually the whole ISO is like 90 megabytes. So what I have here now, we can see that I have two drives. I have here AD0 and AD1 virtual drives. Both have 4 gigabytes. And I would like to now to have a full ZFS-on-root install on these two drives in mirror mode. So we have a ZFS install script that has a context help here inside. Lots of flags, lots of options. We have also a nicer help. So if someone wants to directly understand what's inside, it's written here. So with examples, very important at the very bottom. So we can follow these and install it. So let's make a ZFS install on AD0 and AD1. Name of the pool, let's pick the Solaris way. Our pool, standardly it's taken the our way tank. Let's make a V16 pool. And we can do like a 502 megabyte swap partition. And let's say we want compression and we want Fletcher 4. So let's see what happens. Of course, the main thing I import, you have to give the path to the file. As I said, that you can choose the compression between bzip to xz and so on. The script detects with the file utility what type of archive it is, so that it picks automatically the correct utility to extract. So let's see what happens. So as we can see, I didn't tell him that I want mirror. So when I pick two drives and I don't tell him that it's a mirror mode, it's automatically pick mirror. Other side, you have to tell him that you want them in RAID 0 mode, that it's a one pool. So now the distribution is extracted into the pool that was already created with the partitions. The swap partitions are on both drives because the drives are in a mirror mode and we want them to be same. The extraction takes, again, some time because of the notebook first, and second because we have selected also compression on the system. Okay. Now the final part. So now it's complete. What we can do now, it's mounted in MNT, and what you can actually do, if we just look at the ZFS list, then we can see that it's mounted with the mount root command option. And if we now you can now chroot to MNT and do some operations there as if it was already the final system. So we could actually put these packages inside. Or I can do it with nullfs or whatever. Oh, yeah. Let's add it. But actually, you don't have to do anything. You could now reboot, but you need console access because you have to set the password. There is nothing configured. It's like a very clean install of FreeBSD. So, whatever. And there is no root password set, so let's boot without it. Let's leave the chroot and just do a reboot. And the system will now be booting from the hard drives. Oracle is a friend of us all. So let's see. Now we are, is it still booting the CD loader? I don't want that. So, no CD-ROM. And again. Okay, better now. So, this is now from the virtual disks. It will now go faster because there is no ZFS-root anymore, no mfsroot to be loaded. But if you have a normal server or something, it goes really quickly, everything, all of these parts. Nice timer. So, and here we are. Waiting for USB. So what we have here, we have a zpool where everything is installed. Again, I pick a layout that might be, again, a point of discussion. I picked that it's like very close to old UFS layout people have been using, that they have a TMP user and one on a separate partitions. For example, then users can replace the TMP partition with a memory TMP partition. Many people use that from TMP MFS. And the whole system is installed in the root partition here inside. And of course, on this system, all operations can be done. And if somebody wants to change the main system, then he can again boot from mfsBSD, import the pool, make any changes he want, then reboot, and you are running again from like with a different configuration or something. Okay. Nice.
Show off.
Good. These are the new features I'm preparing, so for ZFS. Good. So this was the presentation part, and now if there are any questions, I would happily answer them to you.
Any questions?
is there possibility to set GPT labels instead of row device names, like AD0, P0?
At the very beginning, I have been using GPT IDs in the system. I mean, this option is currently not built in, but I'm considering putting it in. GPT labels is a little problem because if you make these labels, you have to label them and you have to pick something. There are no like standard labels. That's a user-specific thing. That means it's your decision how do you label GPTs. But GPT IDs, that's not your decision. That might be a point that could be used inside.
Yeah, I remember. Can you hear me?
Yeah.
I read on your home site that you said that you shouldn't, you couldn't make the images too big because I don't know. There was some panic. You wrote about that.
There is a in Cambridge. I have spoken with John Baldwin about this, and he told me that there is a limitation inside the kernel of the maximum size of this mfsroot that can be loaded. I mean, this limitation can be changed by changing some values inside. But it's not standard anymore if I change it then. So there is some kind of 45 megabyte limitation or something about that.
Yeah, it's from the page table sizes.
Yeah.
The kernel wire uses to wire memory, and they're not big enough to go bigger than that.
Okay, any other questions or ideas or something? I'm always open. At the top there.
Do you consider that the embedded devices can be a target for mfsBSD?
Yes, I'm thinking of that. The main question is the memory. I mean, if you have enough memory, then there should be actually nothing in your way to boot it on these devices.
Yeah, can size of the distribution can be reduced so much that it can fit, for example, in 16 megabytes flash chip?
You mean just this mfsBSD? It has 30 megabytes. That means if you want to prepare this mfsBSD in a way that it runs like a server, that means just you put some stuff inside and you just boot it. I have such routers, for example, that boot it just from a USB stick or something, and they run from this or from a onboard flash memory chip. Yes, I have such distributions that really boot only from mfsBSD, that they don't use any storage at all. So the whole distribution, as I said, has like 30 megabytes. So if 60 megabytes is no problem.
What I am asking is, theoretically, distribution can be reduced even more to fit in flash chips of, for example, Soho routers.
Well, the distribution I'm installing is a full one. You could theoretically install this reduced one. That's possible. That you just copy the mfsBSD as is installed, you copy the whole thing into a chip, and then always boot it, like as a distribution, not as a mfsBSD install. All deleted files are actually in a single file inside the distribution. You can take a look inside, and you'll see all files that are not anymore inside. For example, there is no GCC, there is no GDB, and stuff like this. Yes, it's not part of it.
Okay, thanks.
There is a question.
Hello. I'm wondering if you're thinking about providing something like a Red Hat Kickstart service, meaning that you'd be providing some installation script which would automate all the tasks you are doing. And well, my idea here would be that when you provide the loader count variables, you can also provide some resource like HTTP resource of the Kickstart script or Kickstart-like script, which would automate all the tasks you were performing later on? Were you thinking about such solution?
You mean in an environment, let's say that you have like in a school, you have like 50 computers and you want to automatically install them on.
Yeah.
That's easy to implement, very easy. So I wouldn't see a problem in there. You just add another startup script that does all the stuff you want.
Okay.
And of course, you have access to all of these installation machines via SSH. If you can boot them from the network, it's no problem. You can also provide a script that reads NFS or from THFTP this data, so you can just provide this startup script from a server, actually. That would be also interesting, so that if you want to make any changes, you just change the startup script on the server, and it applies to all workstations you are installing.
Any other questions? If not, thank you very much.